Welcome back to Modern Era Code. Today, we're talking functions and type annotations, because knowing how to properly define your function types can save you from hours of debugging headaches. So, you call a function and nothing happens. Or worse, you get a cryptic runtime error message that makes no sense. TypeScript can help you avoid this, if you know how to annotate your functions properly. Mastering function types not only helps you catch bugs, but it also makes your code more predictable and easier to maintain. In the previous video, we learned how to type our variables. But what about a function? Functions are at the core of any TypeScript project, and defining clear input and output types can completely eliminate entire categories of bugs before they even happen. In TypeScript, you can specify the types of both the parameters and the return values. For example, take this function greet. It expects a parameter that we're calling name. We're typing that parameter, saying we expect that to be of type string, and we're saying this function should return us a value that is of type string. These are called type annotations. This ensures that name is always treated like a string, and the function will always return a string. If you try to pass in a number or an object, TypeScript will catch it before it even compiles. Let's see what happens if you don't define types. It would look like this, like a normal JavaScript function. If you pass it a number instead of using a string, TypeScript's not going to stop you, but at runtime, it could lead to unexpected behavior. You can also define types for anonymous functions using type literals. This allows you to define the shape of a function directly as a type, which can be useful when working with higher order functions or callbacks. Sometimes you might want to make certain parameters optional, or at least provide sensible defaults if none are passed. TypeScript makes that easy. You can make parameters optional by adding a question mark after the parameter name, just like this. We have a function. We named it greetOptional. We have a name parameter that we're saying is optional, as indicated by the question mark. We want it to be of type string, and we want it to return a value of type string. The name parameter is now optional. If you don't provide a value, the function will still work. Now, if you want to assign a default parameter, you can define it in your function signature. Here we have function greetDefault, taking in a name parameter with a default value of modern era code. In this case, if no argument is passed, the default value of modern era code will be used. This makes your code more robust and prevents those undefined errors. Now there is a common pitfall with this. You can't combine optional and default parameters. TypeScript will complain. So for example, if I add a question mark here, you can see TypeScript actually gets mad and says, parameter cannot have a question mark and an initializer. You can easily fix that by taking away either the question mark or the default value. Now, if you prefer the cleaner syntax of arrow functions, TypeScript works seamlessly with those two. You can define the types directly on an arrow function like this. Here we have our function declaration, const greetArrow, takes in a parameter name of type string, and it returns a value of type string. This is especially useful when working with functional programming or React design patterns. You can also add default parameters by adding an equal sign after the type declaration and putting in your default value. Cleaner syntax, predictable behavior. Arrow functions are also perfect for higher order functions. Here, operate takes in two numbers and a function that defines the operation. TypeScript ensures both the inputs and outputs match the expected types. Sometimes you want a function to behave differently based on the types of its inputs. TypeScript has you covered with function overloads. Let's create a function that returns either a number or a string based on its input. Here we have a function we're calling format takes in a value that could be either a number or a string, and we're expecting the output of this function to be a string. We do a check to check if it is a type number, and we return value.toFixed to 2 decimal places, or otherwise we return the uppercase version of the value we passed. This ensures TypeScript knows how the function should behave based on its input type. Mastering function types in TypeScript is one of the fastest ways to improve your code's quality. Optional and default parameters make your functions more flexible. Arrow functions keep your code clean, and function overloads give you type-safe flexibility. Next up, classes and objects. The building blocks of scalable TypeScript. Like and subscribe so you don't miss it. I'll see you there.